So this video is about using reverse biased junction diode capacitance to run oscillators. There's two of them, one around a megahertz and one around 10 kHz, using basically the 1N4000 series diodes. They have about 40 picofarad capacitance. You can use varactors, but they're only about twice as many. That's 100 picofarads, and they cost a whole $1 instead of just 10 cents a piece. This is the schematic of the sawtooth oscillator. LM339 comparator runs between 5 volts and ground, and a little RC network back from the output, this resistor and the diode used as a reverse bias junction capacitor. The pot varies the bias on the diode, varies the capacitance and then the frequency. The comparator has a very high gain, so it doesn't take much of a voltage difference at the two inputs to make the output bang back and forth between the supply and ground. The positive input is biased at about half the supply, so it only takes a couple millivolts of swing at the negative input to switch the output back and forth. So this is what the little sawtooth oscillator looks like, a pot for adjusting the bias. And one little IC, I only use a quarter to LM339. Less than a couple dollars worth of parts. So here's what the output looks like. Notice there's about 5 cycles in the low part of the pulse generator and only 4 in the high. The two frequencies are about 730 kHz for the low frequency and almost 900 for the high. The bit rate's about 100,000 a second. Looks like it works. This is a schematic of the phase shift oscillator. It basically consists of 3 phase shift stages and an inverting gain stage. This is a little RC section, the diode for the capacitance at each of the stages, which basically gives about a 60-degree phase shift. 360s are 180, and then the inverting amplifier is another 180, gives you 360 degrees of phase shift. That's positive feedback. If the gain's greater than 1, it's going to oscillate. All 3 bottoms of the diodes are connected to the bias pot. And this is what the gadget will end up looking like finally. Kind of busy, but it seems to work. So here's what the output looks like with a 1 kHz square wave driving the diode bias line. The high frequency is on the order of almost 11 kc, and the low frequency is about 8. So that looks like FSK to me. Well, this was a fun little project. The ordinary rectifier diodes, 1N4000 series, have a junction capacitance typical of 40 puffs and down as you bias them. I looked in some parts, and the varactor diodes are only about twice that. So you can spend dollars for a varactor diode or just use regular little rectifiers at like 10 cents a piece. So for both these little oscillators, only cost a couple of dollars for parts, and they seem to work fine. Thanks for watching.